Hello everyone. Let's solve daily Leetcode problem given on 9th July 3439 reschedule meeting for maximum free time part 1. I don't know if you have observed the patterns with the daily Leetcode problems given in uh, daily Leetcode problem series. So before we had a problem which was asking us to find the maximum number of events that we could attend. Now it's asking for us to reschedule meetings to get maximum free time. So seems like a funny order, but yeah, this is another interesting problem. Before starting this problem, let us have a small motivational quote for today. Taking the time to learn concepts thoroughly in the beginning may seem slow, but it builds a strong foundation. When you deeply understand the basics, solving advanced problems later becomes much easier because you can connect ideas, spot patterns, and apply core principles effectively. This approach saves time in the long run by reducing confusion and making problem solving more intuitive. Patience really pays off with great confidence and efficiency later. So, reschedule meetings for maximum free time part 1. This is a medium type problem. Let us quickly understand the problem statement. You are given an integer event time denoting the duration of an event where the event occurs from time 0 to event time. You are also given two integer arrays start time and end time, each of length n. These represent start and end time of n non-overlapping meetings where ith meeting occurs during the time start time and end time of I. You can reschedule at most k meetings uh, by moving their start time while maintaining the same duration to maximize the longest continuous period of free time during the event. Okay. The relative order of all the meetings should stay in the same and they should remain non-overlapping. Return the maximum amount of free time possible after rearranging the meetings. Note that the meeting cannot be rescheduled to a time outside the. Okay, we cannot reschedule a meeting outside the event. So that's a key point here. So let's look at this example. This would help us better understand this problem. So event time is like a boundary 0 to 0 to the max event time 5, and within this there are certain set of meetings given with start time and the end time. So if we take 0 0, this would give us 1 to 2 there is a meeting. So as we see here, 1 to 2 there is a meeting, and at index 1 there is another meeting happening from 3 to 5. 3 to 5 there is another meeting. So if we want to maximize the free time here, either we can move this meeting slightly backwards and this would create an open space here. 4 to 5 will be a free time and 0 to 1 will be a free time. Or we can take another approach, say we can move this 1 to 2 meeting to uh, 1 to 2 change to 2 to 3, which would open up till 0 to 2 as free time, and that would give a duration of 2, which is the output here, right? 2 is the output. Similarly here, uh, let's say if we move this to this place, that is if we change 2 to 1, then our this new meeting will be 1 to 3, and the new space will be 3 to 9, which will be 6. That's the whole output. So sliding window is a common approach that helps these kind of problems to be solved. So let us look at uh, the approach that we can take to solve this problem. So one thing that we The parameters that we know will be given are event time, k number of max events that can be changed, and start time an array and end time an array. So these are the set of values that will be given as as parameters. So from here, our steps will be, we can find the gaps. Say we can fill it up, such as the start event time minus start of 0. That is the first meeting first meeting. So this will be the one, and also at the end, this will be the first value that we push to the gaps array. And at the end, we also will be having event max time. That is the event time minus the end length time, right? So the last index, and that will give the maximum uh, free time that we have at the start of the event to the first meeting, and at the end of the event to the last meeting. And in the middle, we can calculate the middle free time with the following logic, saying that start time of I minus end time of I minus 1, or the previous meeting. So gap between the next meeting, or that would help us calculate the middle free time. So let's say a specific start meeting, we can compare it with the end of the previous meeting. End of previous meeting. Okay, so once we have all of these, we can, once we have the gaps array populated, gaps array populated, our goal is to maximize free time by uh, k meetings reschedule, right? So that's our goal. So let's set a window size of k plus 1, and let's calculate an initial sub without, let's say, uh, a current sum, or let's call this current sum, and let's calculate it this way. So 0 to I less than window, and also let's also set a boundary condition saying that it's within the gaps dot length times, and also I plus plus. So one thing to note is, let's say we have uh, let's consider this example here. I will just erase all the annotation that I had, and the start time here is 0 start gap. This is the start gap, and in the middle we have this gap, which is 1, and also this gap, which is of length 9 minus 4, which is 5. right? So it would be meaningful for us to maximize this gap, and we have a k value which says we can reschedule n meetings or one meeting. We can reschedule one meeting. So we can reschedule this meeting towards left side. That would give us 6 as a maximum free time. So this is our output here. For doing this, we are firstly calculating the current sum, which we do it this way. So current sum is equals to gaps of I. And next we say result is equals to current sum or all the possible sums, and then we slide across the uh, window size, and I is less than gaps dot length I plus plus. So we calculate the maximum gap with the result or the current sum, right? So, and finally we can return the result value. Okay, having understood this, let's go to the Leetcode editor and let's apply our uh, approach to the solution in Leetcode editor. So this would be the sliding window for loop where we slide the window. We add the new incoming value, and also we subtract the outgoing value this way. So we update the result and we return the result value. Okay, so this should solve the problem. Function is not defined. As you can see, the solution gets submitted. Hope you found this video helpful. Please let me know your thoughts on how the video was helpful to you, and let me know if you find any practical use cases to this problem. Until next time, thank you.